He's one of the most significant scientists of the 19th century, and his work laid the foundation for modern physics, quantum mechanics, and relativity. Today, we explore the life and work of 19th century Scottish physicist and mathematician James Clerk Maxwell. My guest is mathematics educator, curriculum designer, and medical physicist Amos Tarfa, who will help us profile Maxwell and better understand the great scientist's important contributions. But first, let's enjoy music from Scottish Gaelic singer and songwriter Kim Carney. From her second solo album, out this year, Song of the Bald Beast is a traditional walking song that tells the story of a woman who turns into a selkie, a seal-like creature popular in Scottish mythology. Let's listen together now. Welcome to Simply Scottish. I'm your host, Andrew McDiarmid. Well, it's great to release another episode of the podcast. I used to have a lot of time to dedicate to Simply Scottish, but my day job as a podcaster at the Discovery Institute keeps me busy, as well as helping my wife homeschool our 3 daughters. But here we are, and I'm glad you're listening today. If you're new to the show, there are almost 100 episodes in the archive to enjoy, each with at least 2 or 3 songs from Scottish artists, old and new. Plus features and interviews about Scottish culture and history. So, the way to tap into that is subscribe to the podcast on your platform of choice, leave a favorable review, and enjoy the archive while you wait for new episodes. I'd like to give a quick shout out to a few listeners who have recently been in touch with me. James in Mississippi recently came across the podcast. In an email, he says, "I've always wondered why I felt a strong connection to Scotland. A few years ago, I was told by a distant cousin who lives 45 minutes from my town that our Holyfield family roots came from Scotland. So I looked into it myself, and sure enough, right from the Holyfields of Perth, Scotland." Well, James, I'm glad you found Simply Scottish. I'm sure it's going to strengthen that magnetic pull towards Scotland that you describe. Maybe you'll get a chance to visit the country in the near future. I also heard recently from Cindy in Pennsylvania. When she emailed me, Cindy was actually on a trip to the British Isles and heading to Scotland, where her dad's mom's family hails. She was also planning to visit Burghley Castle, as her dad's dad is a Burghley. Cindy was inspired to visit the land of our ancestors after listening to Simply Scottish. We actually have a wee-in episode dedicated to Scotland's historic capital, Dunfermline. You can find it in the archive. Cindy, thanks for reaching out, and I'm glad you enjoyed your trip. If you'd like to connect with me to share your Scottish story, or ask about the music you hear on the show, or just want to tell me you're listening and from where, I love hearing from listeners. Email me anytime at andrew@simplyscottish.com. andrew@simplyscottish.com. You can also connect with me on X, Facebook, or LinkedIn. Let's pivot now to my interview with mathematics educator, curriculum designer, and medical physicist Amos Tarfa. This conversation originally aired on the other podcast I host, ID the Future, a podcast about the scientific evidence for intelligent design in nature and the debate over Darwinian evolution. Amos has a master's in medical physics and a master's in medical health physics, and has completed a year of his PhD studies in chemistry and STEM education. He grew up in Nigeria and came to the United States in 2007 to pursue his college education. Instead of proceeding to medical school, Amos decided to go into education instead. He has been teaching, tutoring, and designing mathematics curricula since 2011. Amos, welcome to ID the Future.
Thank you so much for having me.
Well, let's begin by getting to know you a bit. This is your first time here on the podcast. I know you've met quite a few of us here at Discovery Institute over recent years. Tell us a bit about your background and how you came to have a passion for mathematics and the sciences.
Well, thanks again. I was born in northern Nigeria and moved to Lagos, Nigeria. And right from the earliest days of my life, I could remember I loved pencils, pens, and paper. I always loved learning. And when I moved to Lagos, Nigeria, I was part of the JETS Club, which stood for Junior Engineers, Technologists, and Scientists. So right from elementary school, I was very excited to learn about science and the world. I was also excited to learn about mathematics and patterns. Those were some of my early memories. And so right from elementary school, I got involved with the Junior Engineers Club. After I went to high school, I continued in that tradition of science and mathematics. In Nigeria, you have to choose a track when you get to 10th grade. You either go to the science track, the social science track, or the arts track. And I chose the science track. So spent a lot of time with science. I was the president of the JETS Club in high school. And that's a little bit of my technical sort of background from K-12. I went on to study chemistry, pre-med, and I love studying the world that God has created. And that's my background.
Okay. Now, you've been long inspired by some of the best mathematicians in history, including Sir Isaac Newton, Leonhard Euler, and Carl Friedrich Gauss.
Yes.
Now, part of your philosophy as an educator is that in order to produce top mathematicians, we can learn from the education of those great men. Why is it useful not just to consider their achievements, but how they learned and what they learned and where they learned?
I believe that understanding what kept them up at night is a key element of learning how to inspire us children today. I know you didn't mention one of the other ones, Michael Faraday. Whenever I hear his name, even if I'm having a bad day, I smile because Michael Faraday was a boss. I love Faraday. And I think about 1831 on Christmas Day. Why is Michael Faraday doing experiments on electricity and magnetism in the 1830s? Why was he staying up at night, right? Why was he doing what he was doing? Well, there's some history there with Voltaire and Ampere and Ostad. Okay, now I'm getting a context to what's going on in the 1800s. That gets me excited to then want to dig deeper into what Faraday was trying to accomplish. I believe that if we can see what kept them up at night, we might just get a lot more students wanting to do calculus on Friday nights instead of doing other things.
Well, that makes a lot of sense, and you're definitely a man after my own heart. I love to get to the bottom of things, to go back to the origin. Whenever I have a conversation with my family, my kids start rolling their eyes when I say, well, 100 years ago, or even more, but I like to give that a little bit of context. Yeah. And not many people think about that in terms of the math education. They think of the nuts and bolts. They think of the repetitive nature of what you've got to learn, but you're really advocating for a bigger picture to that math education, right?
Yeah.
And we can certainly unpack that in the time to come here. But let's delve today into Mr. Maxwell, one of my fellow Scottish compatriots. He is quite interesting in the history of science. Obviously, his life covered the 19th century. Why does he matter in the history of mathematics and science, would you say?
as I jump into this, I do want to mention that the attitude I am calling people to have on the history of science and mathematics is part of the attitude you see in Isaac Newton. It's the
Hmm.
fact that Newton is reading Euclid and Newton is reading Descartes, and of course Blaise Pascal lived around the time of Newton. But the point is that we see some of how they became who they became, and it partly had to do with what they were studying of the people before them. So then Maxwell, when I look at Maxwell, I'm amazed at how much he was able to accomplish in his life, and died at 48, which was the age his mother also died of stomach cancer. And I think that when I look at a life like that and see how much he was able to accomplish, it tells me, number one, it's not about how long, it's about how well. So we need to make the most of the lives we've been given. But let's tie it back to Maxwell. Why is he so important? I think that without Maxwell, modern physics would have struggled a lot. Maxwell is one of the key elements that unlocked a new realm in science. And here's one of the biggest achievements is showing that light was electromagnetic radiation. When Maxwell showed us that, it basically was like opening a door to a whole new realm. And so Maxwell's work in the 1850s, 60s, and 70s was fascinating. I do want to add one more thing about Maxwell that I find quite interesting, and that is his legacy. Maxwell started the Cavendish Laboratory at the University of Cambridge, which I visited last year. And actually, I want to make that every summer. That's my dream, is just to go back and keep learning. But one of the interesting things is that Maxwell died in 1879. And that same year, a German scientist was born named Albert Einstein. And Albert Einstein, carried on. And into the early 1900s, they asked Einstein, do you stand on the shoulders of Newton? And he said, no, I stand on the shoulders of Maxwell. That was sort of one of these conversations that I've heard from multiple people about, Einstein and Maxwell's relationship, how he looked up to Maxwell. But I bring up the Cavendish Laboratory because J.J. Thomson discovered the electrons in the Cavendish Laboratory. We could go down the list. They have almost 30 Nobel laureates out of the Cavendish Laboratory, between the Cavendish Laboratory and the Royal Institution, which have some relationships, especially back in the day, they had more. So I bring that up to say that Maxwell's legacy, he set them up for success. And today, we're benefiting from what Maxwell did back in the 1870s.
Okay. And that sort of leads into my next question. How exactly was Maxwell viewed by his scientific contemporaries? And how has history judged him, compared to Newton, Faraday, one of your favorites, and Albert Einstein? Do you think he gets a fair shake? Do you think he's remembered as well as those gentlemen?
I've seen places where they would put Maxwell, Newton, and Einstein, right? Like sort of the top three. I've seen those kinds of, rankings. I would say that, Newton was Newton. Newton was unique. And I know today is not about Newton, but without Newton, there wouldn't be a Maxwell at the level of Maxwell, right? So Newton, did something. And Newton was willing to acknowledge that if he has seen further, it's because he stood on the shoulders of giants. Well, who were those giants? Copernicus, Kepler, Galileo, which, by the way, Galileo died the year Newton was born. That's another interesting set of dates. But anyway, so Galileo dies, Newton is born, Newton does what he does. And I think that Newton is phenomenal in giving us the keys to the calculus, as well as Leibniz. But we're looking at Newton for a second. Now we fast forward into the 1800s. Faraday's experiments were found to be, very good. He was a very good experimental physicist, but he was not a mathematical physicist. Faraday needed Maxwell's equations. Faraday needed something more. And that relationship should become a movie, by the way, of how that connection that happened when Faraday meets Maxwell and Maxwell shows Faraday's experiment from a mathematical perspective. I would argue that because of what he did on top of what Faraday was doing, because what Faraday was doing was already very phenomenal. Now you add mathematics to it, and it went to another level. So I would say that most physicists you talk to, actually, Richard Feynman and another physicist, here's part of what they would say about Maxwell. They would say that if our civilization ended and there was only one thing that was remembered, it would be Maxwell's equations. That's what they said about Maxwell. So Maxwell was not a joke, that's for sure. One other comment they made about him, what his contemporaries made was, can you ever be wrong on your problems? Like, that was what somebody said about him at one point. Like, come on. Like, he was 15 years old when he was publishing math papers. That's the kind of man he was. Well, the kind of boy he was, and then he grew up to become a phenomenal mathematical physicist. By the way, the kinetic theory of matter in chemistry, thank Maxwell for that as well. So Maxwell isn't just tied to physics. It's the type of the mind he had that went into multiple domains. And of course, Boltzmann took on some of his work, and that's another scientist for another day. So,
Sure. Well, what do we know about Maxwell's personal faith and how it influenced his view of science?
well, I find that it's not just that he professed to be a Christian, and which Faraday was as well. There's actually a paper I have from Ian Hutchinson here about Maxwell and Faraday and their faith, the life and faith and genius of Maxwell and Faraday. So they're, diligent man of faith, but it's his humility also. It's one thing to say that he believed. It's another thing to also realize that he allowed his faith to govern how he lived his life in such a way that people would have to testify that he was different. So he was a devout, Christian. He memorized all of Psalm 119. I mean, think about it. Psalm 119 is difficult enough. It's not a story. It's 176 verses that are going into different aspects of God's commandments and judgments and laws. And Maxwell memorized it. So that was the type of man he was. He believed that God's word laid the foundation for how to live.
And there's something above the doorway at the Cavendish Laboratory.
Yep.
I was going to ask you about that. Particular writings, quotes, or prayers from Maxwell that highlight his belief in the design and order in the universe. Give us a few hints at that.
Well, I mean, great are the works of the Lord, I think it's great are the works of the Lord, sought by all who take pleasure therein. Great are the works of the Lord. So clearly his physics was built upon this premise, which, if we look back at Kepler and Newton, they spoke in similar ways. Great are the works of the Lord. So we see that about Maxwell. We see that he talks about the fact that all truth goes back to God. Like that, there's those types of quotes as well, where he understands there's a deeper level to reality that goes beyond what is seen. And let me also mention one other aspect of Maxwell's faith that I believe is very interesting. Think about the fact that light as electromagnetic radiation, the fact that there's more to light than what you see. In Hebrews 11 in the Bible, it says, faith is the substance of things hoped for, the evidence of things not seen. Maxwell was willing to believe in the unseen. That is a very interesting observation. To when your worldview allows you to believe in the unseen, you can actually potentially begin to discover more than if you think all there is all that you see and can touch.
Yeah, very interesting. Now, Maxwell was among other prominent 19th century scientists like Faraday, Louis Agassiz, who continued to advance this natural theological tradition that was inaugurated by Robert Boyle, Isaac Newton. But other scientists began to regard the witness of science as hostile to a theistic worldview, or at least merely neutral, especially after Darwin's theory, started to percolate. You had scientists who either disavowed themselves of a theistic worldview or were neutral on it or even considered it hostile. But Maxwell seems to be different. How did he reconcile his rigorous science with his openness to intelligent design arguments?
You bring a good point, and I want the audience to remember that in the 1850s, at this point, you have Darwin's book is coming out 1859. You have Karl Marx doing some of his writing. There's all of this stuff happening now. 1871, the Franco-Prussian War, and the role of Germany at this time in history. I think that faith element. I think about the Reformation in the 1500s and Germany's place in history and how things changed so much by 1870, where they had moved away from some of those views that traditional Christianity would have called for. But I think Maxwell, as a Presbyterian, I think that what is the church? What does the church teach, or what was the church teaching at this time? And I think that Maxwell, devout in his faith, seeing what the church was teaching, was showing that there was no conflict at this time, right? Even though Charles Darwin's book was a turning point, I think that Maxwell was willing to choose God's word above whatever the consensus of the time might have been. He did not see a reason to have a separation. And I agree with him wholeheartedly. And I think that one of the reasons is this. This is something I'm actually just realizing. Isaac Newton was a giant who went to the same college as Maxwell. And for Maxwell to have seen what Isaac Newton, did and the Principia, I think that type of giant being close. Newton died in 1727, so Maxwell was living about 115 years after Newton. I think the mood was still ripe for these kinds of conversations. But after 1879, when Maxwell died, I feel like a lot changed in the world. And this coincides with Darwin, Marx, Nietzsche, and some of these other writers that came right after.
Yeah. Yeah, one of the things I've learned about the history of modern science is, and Stephen Meyer and others have written about this history, and I don't think it's very well known. The Judeo-Christian ideas that really got modern science going. Not to say that science wasn't happening in many other cultures, but what was it that really kicked modern science off and the scientific revolution? Well, it was these Judeo-Christian ideas about the intelligibility of the universe, that it could be understood, it could be studied, it could be, intelligible to us. Maxwell definitely a model of, that belief that you could study nature and ascertain things about its design and about its designer. How else do you think Maxwell's life illustrates this harmony between faith and reason? As you say, he didn't separate them. He didn't see one as the enemy of the other, which was definitely a popular theory that sort of emerged in the late 19th, early 20th centuries. Was his life showing this harmony, do you think?
I think his life was showing this harmony. As a matter of fact, close to the end of his life, he had left Cambridge and gone back to Scotland. And Maxwell, even though he was smart, he calculated, he explained the rings of Saturn before. 100 years before we found out the full composition. Maxwell was right. He showed it mathematically. And we know all these amazing things he did. But Maxwell, towards the end of his life back in Scotland, people said, even when he was sick, that he had a joy to him. When you know where you go after you leave Earth, it changes everything. And Maxwell's mind was focused on that, sort of, I know where I'm going, and he had peace. And that, reading that about Maxwell, I think was very powerful. Because I think that what we would face today is this reality that we are blessed with so much technology, which, by the way, without Maxwell, you and I will not be having this video conference call. So he's the father of electrical engineering. I forgot to say that. So anyways, you look at Maxwell's life in that context and you realize that, he did all these things. The time came for him to go back, and he went back to Scotland, to his family home. There were times where he faced rejection, and Maxwell still pressed on. And, as I said, he died young, but he loved the Lord and he loved truth, and he wanted people to understand the world that God had made. And then he left that legacy, which, again, the Cavendish Laboratory till today is a serious place. Actually, a few years ago, they released a book called The Legacy of James Clerk Maxwell, the history of Cavendish Laboratory. That book just came out, and I have a few copies that I picked up. Was able to actually donate one to the Hewell Center in England. I left it at Cambridge for the center when it was launched.
Oh, great. Yeah. Yeah, well, as you know, ID the Future explores the evidence for intelligent design as well as the debate over evolution. Now, let's place Maxwell in the context of Darwin and his theory. You say Maxwell was born in the 1830s, is that right?
It's 1831. Yep.
Okay. And Darwin released his abstract on the origin of species, 1859.
Yep.
Do we know what sort of immediate response Maxwell had to Darwin's ideas? Did they ever communicate with one another as writers, correspondents? What do we know about what Maxwell thought of Darwin?
So I actually have never thought of that question in depth, which I'm going to go look it up. But let me say this. As a Maxwellian, who really believes that Maxwell was unique, I will say this. As a mathematical physicist in training, but I'm a medical physicist who's actually studying to be a mathematical physicist in training. I don't think I can take Darwin's work seriously in that sense, because the mathematical probability and the alternative explanations are quite strong against the idea that we can get everything we have from what Darwin's theory is saying. What I'm saying is, from a mathematical perspective, I'm troubled by Darwin's work. I see a lot of improbability that it just makes me uneasy. And I know that the world might have been craving for an alternative explanation, but if we really look at the probability in question, I think that we should be honest with ourselves and at least admit that should not boldly profess that Darwin's theory can hold weight and take their thinking seriously, because as C.S. Lewis says, how do you explain materialism as the basis for your own cognitive abilities at the level that we're using to explain your theory? I have serious concerns from a mathematical physics perspective. I don't know what Maxwell himself would have said, but I just know, as one who has studied him quite a bit and others like him, there would be some serious pushback to some of those ideas from Darwin.
Yeah. And as you probably know, we have folks like Stephen Meyer and David Gelernter, David Berlinski, who have been probing the mathematical limits to Darwinian evolutionary processes. And as you say, there's certainly a lot to be troubled about when it comes to trying to credit this unguided process with all of the information that has come about to produce the diversity of life we see.
Yes,
There are
sir.
certainly some formidable mathematical challenges. Now, back to Maxwell here, can you share a few examples of where his discoveries point us toward a deeper understanding of the order, the design, and the meaning in the universe?
The speed of light, actually, he did work on that as well, by the way, which is fascinating. Man, it's amazing to think how one man could be in so many fields, as I said, so anyways, he did work with the speed of light, which is a critical element to some of the work in modern physics later on. Maxwell was very particular about precision. He was very particular. Now, why would you be so particular about some of these things, except for the fact that there is a designer and one who has ordered the universe to be a certain way. So now you're studying his world, right? People like Kepler talk about thinking God's thoughts after him. Maxwell was of that kind of, thought process. Now, Maxwell's work gave rise to the work of Heinrich Hertz, the man who the unit of frequency is named. So Maxwell's work kind of gives us a little bit into that world as well. He unlocks this door, and this door again is solid to the point where it can allow for future discoveries to have solid footing. So I think that if he had not had some of these principles in order, which he believed, of course, God created the world and all of that, if he didn't have that in order, the future theories would have broken, if that makes sense. So clearly, he came upon a very solid set of principles that govern physics today.
Definitely illuminates that saying that came from Newton, standing on the shoulders of giants, recognizing who came before you, who set up the theories and laid the foundation for your own work.
Yes, sir.
Now, if you had to distill Maxwell's worldview into a lesson for today's scientists and students, what would it be? How would you put it?
Humility. Humility and willingness to acknowledge when some scientists today make it seem like you have to know everything, or sometimes they don't say that you have to know everything, but the sometimes our attitudes speak louder than our actions. And some about, maybe what we think about ourselves. But Maxwell's attitude was one of humility, intellectual humility on another level. And that is the type that makes you question things that, if even if you wanted to believe a certain thing, you now are willing to face the fact that, I could be wrong on this. So let me dig a little deeper and let me be willing, let me be willing to dig deeper if I have to. So that's number one, is humility. Number two, collaboration. Remember, I mentioned that Faraday wasn't good at mathematics necessarily at the level of Maxwell, because Faraday was actually a middle school he had a middle school education, basically, right? I was going to say a middle school dropout, but part of it is he couldn't afford much. He used to eat a loaf of bread over 7 days. Someday we'll talk about Faraday, but Faraday was poor. When he died, Faraday got a house from the Queen of England. That was the kind of man Faraday ended up becoming. But Faraday was good at experimental physics. Then he met Maxwell. Maxwell's ability and willingness to collaborate. So when I think of collaboration, humility, intellectual humility, I distill those and say, scientists of today, can we please look back on Maxwell's legacy in those domains, and also laying the groundwork for future generations so that they have solid footing to carry on the work that we do. I think those are some things I see from Maxwell's life.
And definitely humility needs to be in greater supply, that's for sure. We get amped up about politics, and that can sort of play into things. But really, the data is what we've got to pull out of our experiments and investigations. And we want to avoid the extra layers that we can put on, the hype, the interpretation a certain way, the narrative. None of that is as important as the data and the scientific facts. And you've got to handle those with care and with humility, as you're saying.
Yes.
And James Clerk Maxwell, a great example of that from the past. Now, Amos, this sets us up for a separate conversation. We're going to explore your vision for a math education and how we can train up a new generation of James Clerk Maxwells. I look forward to that part of the discussion. You're going to tell us what you've learned from studying math education in America. You've been teaching it a while. You've been developing curricula. And you've noticed some things about what we may or may not be doing right that can enhance math education. So we're going to discuss that. And for now, where can people go to learn more about your work, Amos?
So I have a website called amosthemathguy.com. So amosthemathguy.com will show them some of my work in mathematics education. One of the main materials is called Counting to Calculus. And so there's a YouTube channel for that work called Counting to Calculus. So amosthemathguy.com would be my recommendation. And from there, they can see all the different projects I'm doing in math and science, as well as history and philosophy of science, which I love. And Dr. Stephen Meyer's book, The Return of the God Hypothesis, of course, is an excellent resource tied into the work that I do in the history of science. So, but yeah. amosthemathguy.com.
That was Amos Tarfa, helping me to profile 19th century Scottish physicist and mathematician James Clerk Maxwell. In a separate episode of ID the Future, Amos has another conversation with me about how to train up the next generation of Maxwells. That is, how to take math education, as it is today, and make it more successful, and how to help young people appreciate the fuller picture of not just the numbers of math, but the stories and the reasons and the people who push the boundaries to discover new horizons in science and mathematics. We need more of that today. To hear that and other episodes of ID the Future, go to idthefuture.com or look it up on your favorite podcast platform. Well, that concludes today's episode of Simply Scottish. Remember, if you haven't yet, you can enjoy almost 100 episodes of Simply Scottish by tapping into our archive. Just subscribe to the podcast on your platform of choice, be it Apple Podcasts, Spotify, Audible, Amazon Music, or the like, and start browsing through the offerings. And if you'd like to reach out, find me on X, Facebook, or LinkedIn, or just email me, andrew@simplyscottish.com. We'll close the show with more music. This is a recent single from Glasgow-based folk quartet Gnoss, an uplifting statement of continued form from a group at the forefront of Scottish traditional folk music. The song is called He Up. For Simply Scottish, I'm Andrew McDiarmid. Thanks for listening.
Simply Scottish is hosted and produced by Andrew McDiarmid. Show content, copyright, Simply Scottish Media. All music is used with consent of copyright holders. Continue your Simply Scottish experience at simplyscottish.com. Thanks for listening.